Assalamualaikum and very good day to our lecturer, Prof. Makya TS Dr. Muhammad Zahir bin Hassan, and to all my friends. Today, our group going to present our assignment, which is Conduction Graphical Analysis on Heat Transfer. First of all, I'm going to introduce to our member. The first member of our team is Muhammad Syafiq bin Muhammad Sharif, and second is SASITARAN, anak lelaki VARATHARAJOO, and third is Tan Wei XIANG, fourth is myself is Muhammad KHAIRUL bin ROSLAN, and lastly is Muhammad SHAHUL IQMAN bin JASDIMAN.
Hi, my name is Muhammad Syafiq bin Muhammad Sharif. Today I would like to present about the introduction for this assignment. What is a heatsink? Heatsink is a passive heat exchanger that transfers the heat generated by an electronic or mechanical devices to fluid medium. What is the purpose? To keep the component safe from overheating. How does it work? Heatsink works by redirecting heat flow away from hot devices. For the objective, first, to create two types of heatsink using SolidWorks software. Second, able to learn how to create and run the heat transfer simulation on SolidWorks software. And the last thing is to show the temperature distribution along the heat transfer surface of heatsink.
Good evening everyone. Right now, I am going to present about the design for our group. As you can see from the front side and the right side, those are identical shape, and the amount of fin that we are using is 20 fin, which is there are 5 fin for each side. The dimension for this design is 40 mm times 31 mm. As for the thickness of the fin is 2 mm, and the total thickness is 18 mm. As for the second design, the amount of fin that we are using is 18 fin, which is there are 8 fin on the left side and 10 fin at the right side. The dimension for the left side of the fin is 40 mm times 35 mm times 2 mm, and for the right side of the fin, the dimension is 20 mm times 35 mm times 2 mm, and the dimension for the whole design is 40 mm times 40 mm times 40 mm.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad KHAIRUL and I'm going to show you how to create the simulation on SolidWorks software. First, we need to create the new study. Then we choose the advanced simulation, which is thermal. After that, we're going to apply the material. I use the material 6061 alloy. Then apply. After that, we're going to apply the heat power, which is 63 watt. Then we need to select the entity, which is the bottom side. After that, we're going to apply the convection. For the entity, we're going to select all exposed faces except the bottom side. Then for the convection coefficient, we're going to put 5.03, and for the bulk ambient temperature, we're going to put 307 Kelvin. After that, we're going to create mesh. And lastly, we're going to run this study. So this is the final result of simulation. Thank you.
Now we see the result. Now we see the result for the temperature data for design 1. This is heat sink made out of aluminum alloy. It's a conventional heat sink, but parallel to opposite side. The maximum temperature is 7.617 E plus 2, that is around 488.5 degrees Celsius, and minimum temperature is 7.527 Kelvin, that is around 479.5 degrees Celsius. This is the design 2, the temperature data for design 2. This is a heat sink that made out of 6061 aluminum alloy. It's a mixture of conventional heat sink and sewage line fin, as we can see here. The maximum temperature for this design is 6.168 Kelvin, that is around 343.65 degrees Celsius, and the minimum temperature is 6.064 Kelvin, that is around 333.25 degrees Celsius.
So next is our discussion for this assignment. As you can see, this table shows us maximum temperature, minimum temperature, and temperature difference. For fin design 1, the maximum temperature is 7.617 exponent 2, and it's a little bit higher than fin design 2, which is 6168 exponent 2. The minimum temperature 7.527 exponent 2, and for fin design 2 is 6.064 exponent 2. And the temperature difference, fin design 1 is 0.09 exponent 2, a little bit lower than fin design 2, 0.104 exponent 2. Next is the importance of heatsink. We have 5 points to determine. As you can see, point number 1 is to maintain thermal stability in limits for every electrical and electronic component. Number 2, cool the central processing units and graphic processor of a computer. Third is used for thermal energy management. Fourth, prevent the system failure. And the last one is used to spread heat in the system. Okay, this is our last slide, our conclusion. For this heat transfer assignment, we can conclude that we learn how the heat flow in the fin surface, and also we learn that the heat transfer by the fin is depend on the length, angle, area, and the shape of the fin used. And the best design of conduction heat transfer is design 1, because this design have more fin than design 2, which result is increased efficiency of conduction in heat transfer.